Hey Algebra, let's go and make our answer key for Unit 8, Lesson 11. We had these perfect squares, and it says which expression is equivalent to this? Well, here's the thing. If I took that x and that minus 6 and that x and that minus 6 and I were to multiply them, or if I were to FOIL that out, multiply it by itself, I would get an x squared part. Great. I would, this is not equivalent. I can rule that out. Okay, I would get an x squared part. Great, thanks. Those have x squared parts. The other part I get in the corner would be negative 6 times negative 6, which would be positive 36. That'd be positive. This has a positive 36. That has a minus 36. That doesn't fit. This doesn't fit. We're done. But for the heck of it, we would also get minus 6x and a minus 6x. That would combine to make negative 12x. That fits. This is the one that matches. Write each perfect square expression in factored form. So this is a perfect square. Now, you could think about this with the area model, and you could say, well, there's going to be an x squared, there's going to be a 9 in the corner. You start in the corners, and then you take this number and you split it in half into a 3x and a 3x. All right, and then you know that this has to be an x plus 3 and an x plus 3. So how do we write it in factored form? I'm going to write it above here. In factored form, it would be an x plus 3 squared times itself. So that's what I'm going to do for each of these. All right, I'm going to write them above just so that my work is separate from my answer, and I can have a clear spot for my answer. X times x would make x squared. What times itself would make 64? Again, focusing on this box, x times x, and what times what makes 64? Well, you know, 8 times 8 makes 64, but this has to be a negative 16, so this has to be a negative 8, and this has to be a negative 8 when we split it in half, so this is a minus 8, so x minus 8 squared is our answer. Same thing with this. We have a minus on this inside, so I know that these are going to be two negative numbers. It's going to be x minus something. We'd have our x squared. That's an x times an x. 36 is 6 times 6, but it's going to be a negative 6 times a negative 6. So that we get minus 6x minus 6x. That adds together to make negative 12x. And the last one. Okay, look at what they did here. We got that, we got this. Well, if we take the x squared, we put it here, and we take 5x. All right, we get x and x. We take 5x, we split it in half. We would have 2.5x and 2.5x, 2.5x. If we multiply 2.5, now they're writing it as like 2 and 1/2. If we multiply 2.5 times another 2.5, yeah, oh my God, they're doing this. Here's the thing. Take the fraction 25 divided by 4. We get 6.25. That is the same thing as 2.5 times 2.5. They are just disguising it in fraction form. So it's going to be x plus 2.5 squared. All right, that one's a challenging one, definitely a spicy one. Select all the expressions that are perfect squares. Now these, they told us were perfect squares. These we have to check. If I multiply 5 times 5, I get 25. And if I add them together, that is half of this 10x. So 10x split in half would be a 5x and a 5x. This one is, that one works. This one here, if I split the middle into a negative 5 and a negative 5, if I square negative 5 times itself, I do get positive 25. That's a perfect square. This one doesn't have a middle term. It's not a perfect square, so that's no. All right. Let's jump to this one, a half. What's a half of a half? A half of a half is a fourth. And if I take a fourth times a fourth, we multiply across, I get 1, 4 times 4, 16th. I get 1/16. This one checks out. That is a perfect square. Is this the same thing as multiplying it by, well, if I were to, x minus 10, if I were to rearrange this one, it would be negative x plus 10. That's not the same thing as this, so this is not a perfect square. This is two different things here. And it's going to be the difference of squares, but anyway, or not quite. Yeah, all right, anyway. This one, I could flip around this to write it as x plus 3.5. And in that case, it is identical to this one. It would be the same square, x plus 3.5 and an x and a 3.5 on either side. This wouldn't be the same thing on both sides of the square. So this one is a perfect square. That one's not. All right. Let's move on to 5. Fill in the blanks, complete the squares. What's half of 24? Half of 24 is 12. So 12 times 12 would be 144. We're going to have a positive 144 here. All right. Some number. Ooh, a negative number. Okay, 64 is 8 times 8 to make 64, right? 64. All right, and an x times an x would make that. So, but here we need this to be two negatives. So 8 and 8, they would both have to be negative 8, negative 8, negative 8, negative 8. So negative 8 times negative 8 is positive 64, and if we add them, we get negative 16x. Okay. And x squared minus 2x, split that in half, you get negative 1. And that negative 1 would be multiplied by itself to get that corner piece. Negative 1 times negative 1 is positive 1. Take this, split it in half. What's 2/3 split in half? Well, that's 1/3. And if you were to multiply a third and a third, all right, x and an x, so we got our x squared. This is going to add up. A third times a third, we multiply across. All right, you can use a calculator, but we multiply across, and 1 times 1 is 1, 3 times 3 is 9. We would get 1/9 plus 1/9. Honestly, we can stop right there for homework. That's good enough for practicing perfect squares. There are a few more on the back, but take care, folks. Bye.